Hello, everybody. Today we're going to go through thermal stoichiometry. I know this is a difficult subject for some of you guys thinking about stoichiometry, but I'm going to try to make this as easy as you can understand this. Okay. So, first, let's start talking about our endothermic and our exothermic. Endothermic energy is what to the surroundings in the reactions. In an endothermic, you should say energy is absorbed. Energy is written on what side of the equation? If it's required, then that means that it is going to be on the reactant side. The sign of the delta H of the reaction for an endothermic reaction is positive. In the reaction, when you're holding an endothermic reaction in your hand, it will feel cool to the touch. An exothermic, on the other hand, energy is released. If only I could write, apparently. Energy is written on the product side. We're producing heat, so it's on the product side. The sign of the delta H of reaction. If I'm losing heat, I'm producing it, it's going to go out as a product. It's not going to be something that is used in the reaction. This energy is negative. Remember, when we say the sign of the delta H reaction is negative, we're not saying that there's a such thing as negative energy. What we're saying is that the energy is moving away from the system. Okay? So if it's moving away from the system, it will feel warm or hot to the touch. So, like we said up here, if the energy is listed on the reactant side, such as this one here, it's on the reactant side.
Thank you.
This is an endothermic reaction. Okay? What this is saying is in this balanced chemical equation, every one of these recipes requires 791.4 kilojoules for one batch to occur. Okay? It's saying how much heat will be transferred when 6 moles of sulfur react with an excess oxygen. This recipe only has 2 moles of sulfur. So the difference is I can make 3 batches. If I'm making 3 batches, all I have to do is 3 of these. So I can do this. The easiest way I would say to do it would be set this up in a Bca chart. So if I say I have 6 moles here, I have excess here, I have this, I don't know how much of this, because that's what I'm trying to find, right? And then I have 0 of this. So I'm going to make 3 batches. So I'm going to use this times my coefficients to find my change line. This is where it's a slightly different than what you guys have done with Bca charts before, because we have this number here. We're going to treat it like it's a coefficient, but in the before line, we're treating it like the variable that we're solving for. So in this change, I know 3 times 2 means I'm going to make 6 batches. 3 times 3, I'm going to use 9 of this. 3 times this. Now, this is where we're going to get our number that we're looking for. 3 times 4 is 12. 3 times 1 is 3, so that makes this 4. 3 times 9, everybody got that? 27. And then we're going to have 3 times 7 is 21. That makes this 23. So 2,300 374.2. That's kilojoules. That's how much heat will be transferred if I am using 6 moles of sulfur. Hopefully that's making sense so far. Now, if that doesn't work for you, the other way to do this would be if I want to know X kilojoules for 6 mole of sulfur. So this would be equal to 791.4 kilojoules for 2 mole of sulfur. So you would take 6 times this, then divide it by 2. The X would be equal to 2374.2 kilojoules. Either way, I'm okay with you finding this. Okay? Doesn't matter to me which way you use to find it, as long as you can get to the correct answer and you're showing me how you got it. Okay. Example number 2. The energy is on the product side. So when we look up here at the top, energy on the product side means that this is an exothermic reaction. Okay. I'm going to do both versions again so you can see it however you want. So 4 moles of carbon react with excess oxygen. This one here, we're not even going to worry about this one. And we're going to use this right here. This is our X. This is what we're looking for. Okay? So 4, I'm going to make 4 batches. 4 times 1 for my change is minus 4. 4 times 1 is minus 4. 4 times this. Now, 4 times 5, here's my 20. 4 times 3 is 12, so that makes this 4. 4 times 9 is 36. So that's going to be a 7. And then 4 times 3 is 12. That's going to make this 13. Okay? So the amount of energy we're going to use is going to be 1374.0 kilojoules. How do we find that? Over in this way. X kilojoules over 4 mole of carbon is equal to 393.5 kilojoules over 1 mole of carbon. X is equal to 1374.0 kilojoules. Okay, this is how you do thermal stoichiometry. We're treating the number of kilojoules as if it is a coefficient. The ratio then becomes equal, just like in stoichiometry. You are going to be completing pages 15 through 18 either in class or homework. So you need to be working on this, okay? Please be nice to the sub and have a wonderful, wonderful day. I will see you tomorrow.